Swayam Prabha. Digital India. Educated India.
So, hello student. So, we are at module 8 chemical transformation, so in the same function element. So, today we are going to talk about solid residue generation, characteristic and treatment. As I had discussed in the previous classes, there are two major issues in the incineration process. One was the polluted gas, that flue gas need to be treated properly before stacking into the atmosphere, and another major issue or environmental issue from incineration plant is solid residue production, and that quantity is very large. And again this as I told about characteristics also is again depend upon the feed. If suppose segregated waste is getting feeded into the incineration one. So, obviously, the solid residue characteristics also will be somewhat able to utilize for to produce some other kind of product. But suppose unsegregated waste or maybe some uncombustible matter has been added into the incineration plant. So, obviously, those kind of material will come into the especially in the bottom ash, the slag we called, and that kind of waste again treatment is very difficult, even not treatment, but utilization for the some other uses, that will be also very difficult. So, let us start. First I will tell about the from different way or what different way the solid residue is getting produced during the combustion process or incineration process. So, suppose this is the furnace and this is grate. Okay. This is the one kind of grate. Okay. So, the first will be the bottom ash. So, this is the bottom ash. Once the feed will get combusted onto the grate. So, the combusted material or uncombustible matter will be come out and in the form of bottom ash, that we can say as in slag also. Next is the grate sifting. So, the grate sifting is coming out from the whatever the openings in the grate, because the entire combustion is under the air. Okay. So, you need to provide the air from the bottom, okay, air from the bottom of the grate for the complete combustion of the waste. So, in this opening the very fine particles are coming out, that will called as in grate sifting, and it is also possible that in the feed some of the waste will be easily get combusted, maybe in the very low temperature, could be 200, 300 degree temperature, entire waste is getting combusted. So, because of that also lot of fine particles will get produced and that will come out in the form of grate sifting. Next is the boiler ash, because whatever the heat is getting produced, that is going for the boiler, okay, to produce steam. So, from the boiler also huge amount of ash is also getting produced, okay, that we called as in boiler ash. Next is the economizer ash, that I will going to talk about from where it is getting produced, and fly ash. This fly ash majorly is produced from the air pollution treatment system or whatever the flue gas treatment system, that fly ash will get produced, and along with that acid gas cleaning residue, which we saw in the previous class. Huge amount of the liquid effluent will come out from while treating the acid gases. So, we will go one by one. The first is the bottom ash. So, formed and transported through the combustion chamber on the moving rate and sometimes through a rotary kiln to the quencher. Okay. So, you can see is the bottom ash, because the temperature of these ashes is very high and even the size is small. So, the storage is very difficult actually, and you see in the even the coal treatment plants also lot of particulate matter is getting produced. So, because of that this ashes is directly quenched into the water, not onto the simple onto the particular area or field. When the bottom ash leaves the grate or the rotary kiln, it must be cooled. Okay. So, the most commonly the bottom ash drops from the grate or the kiln directly into quenching tank with the water. So, that will benefit in the both way, because the ash is getting cooled off by quench into the water, and also the storage is also very easy and beneficial. Now, next is the boiler ash. So, boiler ash consists of material that is removed from the flue gas at the cooler surface of the boiler and other heat transfer equipment. So, you can see here this is the ash is getting produced here, okay, onto the boiler. The material that condensed on the surfaces act as an insulator, reducing heat transfer, see reducing heat transfer, and must be removed at regular interval to maintain the process efficiency. So, time to time, because once this particular ash will be onto the surface of the boiler. So, because of that the heat transfer will get reduced. So, obviously the efficiency also will get reduced. So, that has to be removed time to time. Next is the grate shifting. So, this is one of the photo, you can see the grate. So, this is the grate likewise. So, we saw in the one of the lecture of the grate, and this will be the small nozzles will be there, okay, in these areas. So, that air could be available for the combustion. So, pass through the opening in the grate either due to the size, because it melts and it traps in the under fire air plenums located below the grate is referred as grate shifting. Okay. That is the same way from the whatever the openings or nozzles under the grate. Now, next is the economizer ash. So, this is one of the photograph from where the economizer ash is getting collected. So, fine particle collected from the flue gas in the economizer installed in the some boiler system to optimize the recovery of heat from the flue gas before the gas is subjected to a more thorough treatment. Okay. So, that is also very fine particles, and major concentration is fly ash after the bottom ash. So, relatively fine ash particle entrained in the flue gas from the boiler and recovered in the electrostatic precipitator or fabric filter. We saw that in the previous lecture where we discussed about flue gas treatment system. So, electrostatic precipitator, fabric filter or venturi scrubber, the dust is getting removed, and that dust is nothing but a fly ash. Why it is called fly ash? Because this ashes is very fine particle and that will get fly with the temperature. So, because the flue gas will have very high temperature. So, because of that also these ashes is getting flied into the gas, that is why it is called as in fly ash. And you know that the fly ash production is very high into the coal power plants also, and their storage is also very difficult. This is the fly ash storage in bags. Normally this ash is getting stored into the water ponds. So, you see in the most of the incineration facility or even coal power plants, they will have one special area they called as an ash pond. So, means this ash is quench into the water always, because the size is very small. Okay. Now, next is the acid gas cleaning residues. So, solid residue or wastewater generated during the treatment to remove acid gases from the flue gas. Normally, this acid gas we will not consider as an solid residue completely, because it mixed into the water. So, that kind of solids is going into the wastewater treatment facility, and there with the sedimentation process is getting removed off. Now, generation of residues, the quantity, that is the important one. So, this we took this is one of the very good book to read about the incineration facility. So, here you see the typical amount produced, this is in the kg per ton of waste incinerated. So, the bottom ash is 150 to 300 kg, and you see the fly ash 10 to 30 kg per ton of waste incinerated. So, this is the major the production of bottom ash and fly ash. These are the major production in the solid residue, and flue gas cleaning system also with the dry process. We saw the two major processes, the dry process and wet process. There also the large amount of solid residue will get produced, okay, especially in the dry process. Now, the characterization of the residues. So, you see the chemical composition of bottom ash. Okay. So, you see here not only I think these are the good kind of nutrient, sodium, potassium, magnesium is available, but also it will have lot of metals, and these are all carcinogenic metal, manganese, even it will have PCB and PAH also. You see aluminum is there, silica is there, but could be because of these all metals are there, so could be useful for the construction material also, but I think need to get first some kind of treatment is required before getting utilized. So, this is with the bottom ash, and this is another table for the fly ash, this is for fly ash. So, in the fly ash also you see the, I think here the concentration of metals you see here is a very large concentration of metal, and similarly in the fly ash also I think if you compare with the bottom ash, the concentrations of chemical composition is very high. You see here the manganese lead concentration is 11,000 milligram per kg. So, is very high concentration of metal. Okay, here the aluminum is 71,000 milligram per kg. So, is a I think normally is these kind of residues called as an toxic, because and this toxicity is major because of metal concentration, and very large concentration of metals available into this solid residue. So, many times even the coal fly ash also, coal power plant fly ash also is getting utilized for the brick making or for any construction as a construction material. So, always is proposed to do the leachate characteristic study, or we call it as a TCLP experiments has to be done, that is testing for the leachability, and the purpose is that whether these kind of metal is getting leachable are getting leachable once you are using for the for any construction material. Okay. Now, problem associated with the MSW incineration residue. So, due to volatilization and subsequent condensation as well as concentration phenomena acting during combustion, this MSWI, that MSW incineration residues, you have high concentration of heavy metal, salt as well as organic micropollutants. So, the major concentration of heavy metals, so that is problematic. So, it is not simply we can dispose onto the land, because these metals could be leached out and could be entered into the aquifer system. So, it will pollute the entire groundwater. The fly ash is problematic for incineration operation, can cause slagging, fouling in the addition to the environmental issue. So, fly ash is the fouling, slagging could be one issue, and also because these kind of ash is adding as an particulate matter. So, obviously, this is not good for the human health. Fly ash contains heavy metal, high content of easily soluble salts, and in some cases polychlorinated dioxins and furans. This is also important, and one of the lecture I explained already. When the temperature is around 200 to 400 degree temperature, formation of dioxins and furans could possible in flue gas, and once you treat this flue gas, it is always possible that the fly ash could content of dioxins and furans also. The quantity, quality, characteristics of these ashes or residues depend on many factors such as composition of feed. This is what I was talking about, type of incinerator, operating parameter and pollution control technique. But I believe that the major one is depend upon the composition of feed. If your feed is a highly combustible one and is a segregated one, in that case the quantity also will reduce of residue production, also the characteristics also will be different. In some European countries, great effort are devoted to utilization of such residues through various treatment processes. So, because the incineration had started long back in the European countries and some Asian countries like Japan. So, they were tried very hard and lot of effort has been given to get utilize the such kind of ashes or treatment or utilization. If utilization is not possible due to regulatory constraints or any other reasons, these residues have to be disposed in an environmentally acceptable and economically sustainable way. So, if such kind of material is not getting utilized properly, has to be disposed of properly without creating any issue for the environment. Now, we will see the few objective of the MSW incineration residues treatment. So, the objective, what should be the objective, and this text I took it from our solid waste manual in 2016. So, what was the objective? What should be the objective before treatment of solid residue or incineration solid residues? To improve the environmental properties of residue, primarily to reduce the potential leaching of contaminants after utilization or landfilling. See, this is what I was talking about. So, potential leaching. So, there we do the special experiment TCLP. TCLP is a toxic chemical leaching procedure, that is a environmental protection EPA rule. Based on that, we do this TCLP test to know the leaching. To improve the functional property of the residues like strength, bearing capacity and mechanical integrity in relation to utilization. So, obviously, such kind of ashes or residues is mostly proposed to utilize for the construction purposes. So, obviously, the strength, their bearing capacity need to be know or need to be improved, so that it can be utilized for the some particular purposes. And to recover specific components from the residues like metal, see you saw that in the chemical composition huge amount of or very large concentration of metals are there. So, if we are able to separate those metals from these ashes, that will be also one of the benefit could be possible from the solid residue. Now, we will go for treatment of bottom ash. So, there are few technology which I am going to discuss here, and there are a lot of text available, you can go through for the detail. I will just here put it the few points what exactly the meaning of this kind of treatment processes. So, first treatment process is separation process. So, separation is the simplest treatment principle and may include both physical chemical process or combination of both. The particle size separation or sieving, sieving and magnetic separation. For magnetic separation, the target could be to separate the metal or ferrous metals from the remaining ash. Is universally used where MSW incineration bottom ash is processed for the utilization. the bottom ash typically contained 7 to 10% of scrap iron and 1 to 2% of non-magnetic metals. So, at least from the magnetic separator this scrap iron we can easily get separate out, and even particle size separation also is one of the important unit, because for different purposes different particle size is required for the utilization purpose. So, suppose if you are planning for use as an aggregate purpose of these ashes, so the size will be different, and if you are trying to prepare brick or to mix into the clay soil to produce the fired brick, so the size requirement is different. You will be required very fine particle for such purposes. So, it is commonly subjected to coarse sieving, sometime the combination with crushing to remove the oversize material, magnetic separation to remove and recover, ferromagnetic materials and eddy current separation to remove, recover non-magnetic metal including aluminum and copper. So, there are different way the separation could be possible, and also the substantial amount of soluble chloride may be removed by washing of the bottom ash, but again the by washing again will produce lot of waste water by this process. Next is the stabilization and solidification. So, solidification is a physical or mechanical stabilization resulting in a harder or more coherent waste, waste form which increases the strength and tortuosity of the material and reduce the exposed surface area, thus reducing rate of release of contaminants. That is the one target I was talking about, to reduce the leachability. So, leachability could be possible when the more surface area is available. So, if you are able to, by this technology, if you are able to reduce the exposed surface area, so obviously the rate of release of contaminants also will be reduced. Chemical stabilization is aimed at chemical fixation of various contaminants by transforming them into compounds with low solubility. So, this is also one of the very important idea. If you reduce the solubility of these metals, because of that also the leaching could be reduced, and that is I think one idea I am giving, that pH is one of the very important parameter from which we can reduce the solubility, because mostly these metals are get solubilized at lower pH or means acidic pH, and if you are going for maintaining the very large pH of this bottom ash, like if you are maintain about 7, 8 or 9 pH of this particular solid residue. So, it is very difficult to get leached out these metals at this higher pH. So, that is also one of the way where we can reduce the solubility of these particular metals from the solid residue. The solidification and chemical stabilization may be applied separately or combination at bottom ash. The also addition of hydraulic binder such as cement with or without additive to bottom ash will often result in both solidification and chemical stabilization. So, this is also one of the benefit. Next treatment is thermal treatment. So, bottom ash may be treated thermally at different temperature, because if you see the calorific value of these ashes also is very high. So, also could be combusted again, or sintering occurs at temperature of approximately 400 to 850 degree centigrade, may cause fusion and reorganization of solid phases, thereby reducing the availability of various components for leaching. So, I think every time you see the all treatment targets are to how best we can reduce the leaching of these metals, high concentration of metals available in the solid residue. So, melting or vitrification occurs at temperature of 1100 to 1500 degree centigrade. By simple melting or crystalline of heterogeneous products are formed, whereas vitrification, which may require additive, produces a single amorphous glass phase. So, at very high temperature also we can combust and can reduce the leaching of the metals from the solid residue. But I think rate of leaching of contaminants from these products is generally low. So, I was talking about once it is convert into amorphous glass phase. So, the leaching also will be low. Now, the treatment of air pollution control residue, I think majorly is the fly ash. There also we can provide the similar kind of technology for flue gas treatment facilities or the solid residue producing from the flue gas treatment. The first is the separation process. The application of separation process, these residues generally required the residues or the mass steam to be dissolved or suspended in or saturated with water. And for residues from the dry and semi dry APC process and fly ash, the initial treatment step often consists of or include an aqueous extraction operation regardless of the nature of any subsequent treatment step involved. Metals and trace elements may be removed from the wastewater by pH adjustment, which I was talking about, and chemical precipitation prior to discharge or salt recovery. And also the SCl from the acid scrubber effluent could be separated by distillation process or chlorine by electrolysis process. Next is the solidification or stabilization. So, stabilization of APC residue with hydraulic binder such as cement, the similar way of bottom ash could be possible, and for thermal treatment also due to high energy requirement problem associated with the reformation of SCl and vaporization of metal, APC residue generally not treated by the melting process. Okay. Because bottom ash will have large amount of combustible matter. So, that can be used for the thermal treatment, but normally air pollution control residue will not be possible to treat by thermal treatment. Okay. Or similarly with the sintering process may be performed, but I think which have be subjected to aqueous or acid extraction. Now, principles and method or unit operation for treatment of all type of MSW incineration residues. So, these are the three major principles we talked about: separation, stabilization or solidification, thermal treatment. Now, here this table has given the different technology. Okay. This is the different unit operations or technology under the separation. Could be ion exchange process, distillation or electrolysis, magnetic separation, eddy current separation could be possible. Like in the stabilization or solidification, addition of hydraulic binder, chemical stabilization could possible, and thermal treatment like sintering, fusion or vitrification, these kind of unit operation could be possible. Now, some engineering application of bottom ash, I think utilization could be possible, like first for the road construction, bottom ash substitutes sand or fine aggregate in road construction, and will be required large concentration of sand and fine aggregates for the road construction. So, this bottom ash could be substituted this material either as partial or full replacement due to its similar property to natural sand. Okay. Only I think again and again I am saying you do the leaching experiments or the TCLP experiments. If you are not finding large amount of leaching from that particular material, could be utilized for these kind of purposes. Bottom ash can be used in sub base, road base material and as bituminous mixes for the binder layer also. Bottom ash provides aquatic bearing capacity for lower strength application such as sub base material and embankment fills. Next is the aggregate replacement in concrete. So, which I was talking about, like bottom ash can be used in either fine or coarse aggregate replacement. Okay. And if you know the particular size, in the separation process we can separate out the particular size which now we can use for the as an aggregate purpose. The replacement will cause some changes or the properties of concrete such as workability, compressive strength and durability. Now, here I come up with one very small video where the separation process I will show and I think this video is not showing the what exactly is utilization, which I will explain later on.
Did you know that Jersey generates around 100,000 tonnes of rubbish each year? We recycle about a third, and the remaining household and commercial waste goes to the energy recovery facility at
So, this is one of the energy recovery facility where the dry waste is getting combusted, okay, is a incineration, a furnace, and the huge amount of energy is getting produced from the combustion process. This is the bottom ash. See, 12,000 tons in a day. So, this is getting transported in particular island. So, the major objective of use this bottom ash is a aggregate purpose. So, this is for the they are feeding for in the separation process. So, you can see here. So, these are the different screen. You can see the different target size. So, is less than 65 mm. Is getting separated and the more than 65 mm. So, and again this this is getting segregated in fine, medium and coarse material, and here the metal is getting separated by eddy current separation technique. So, this is what the aggregate they produced. So, these aggregates is using for the construction purpose.
Ensures that its operations achieve 100% recycling rates on all the incinerator bottom ash that comes into its facilities. In turn, this means that
And this is the fine material, remained material. This is what this entire mix for the filling of that particular area or for the road construction also. So, there are some more uses of this fly ash or solid residue like building material, clay bricks, and in India also because we are using large amount of fired bricks, and they are always using the clay soil, that is very one of the best agriculture soil we are using to prepare the fired brick. So, in that case it was always proposed that whatever the fly ash is produced in the coal power stations, that ashes could be added into to prepare the fired brick, maybe 5%, 10%. If you add, their compressive strength should be more than the whatever the standards available. And why these kind of ashes is beneficial, because it also contain calcium, it also contains silica, which will also require to increase the strength of the material. Cellular concrete, hollow bricks, emulsion paints or partial replacement of cement. Even in the cement industry also the 5%, 10% of these ashes could be possible to mix into the cement. And some other utilization of the fly ashes for soil stabilization. It is the physical chemical alteration of soil to enhance the physical property. So, it is also possible, and suppose somewhere some particular kind of embankment formation will be required, large amount of soil. So, this bottom ash could be possible to utilize or replace maybe 10%, 20% depend upon the what exactly the compressive strength or what exactly the strength of the that particular embankment is required to prepare and but only the again the same point I am saying, the do the leaching experiments, and if it is under the standard, we can always use for the such purposes. Uses of fly ash for soil stabilization to increase the shear strain, control the shrink, or swelling properties of the soil, and improve load bearing capacity could be possible. So, another utilization for the waste treatment, the fly ash can be used in combination with other alkaline material to transform sewage sludge into the organic fertilizer or biofuel due to its alkalinity and water absorption capacity. So, in many countries, because they are running with the large composting facilities, and particularly the composting of the plants are using the sewage sludge for the composting purpose. So, for that also will be required one dry matter, which will maintain the moisture content and also increase the bulking density of that particular material. So, these ashes could be utilized for such kind of particular areas in some of the countries or developed countries. But if I talk about India, utilization of these ashes, I think before I will talk about the coal power plants, ash production is very large. We are not able to utilize that particular ash, and again I think once you get the large number of incineration plants in India, and you see the quantity production is very large, could be like you can see the per ton of waste incineration, the bottom ash production is around 100 to 200 kg, 150 to 300 kg, means you understand that is a 1 ton incineration, how much bottom ash is getting produced, and also the fly ash. And suppose that plant feeding or plant capacity is 300 to 500 tons per day. So, you understand that how much amount of bottom ash or fly ash is getting produced. So, when you are planning for having the incineration facility in any city, especially in India, need to look upon the two important environmental issue. One is flue gas, how best you will be able to treat that, and before having the incineration facility, you need to talk about the flue gas treatment facility or air pollution control facility has to be installed. And second is need to also have the facilities of utilization of bottom ash. Not only directly the disposal method should not be available, but our utilization should not be possible, need some kind of treatment or at least some chemical experiments has to be do before sending for the utilization purposes. Now, I believe that because India have number of medical waste incineration facilities. So, I am not much aware about that, because there also the large amount of ashes is getting produced. But now under the MSW rule, the utilization also has been given, how best we can utilize these ashes also has to be look upon how best we can utilize the such kind of ashes. So, here we will finish of this particular chapter of incineration processes, where we talked about the first basic whether waste could be utilized as an fuel, followed by incineration, types of incineration, and two major aspects of incineration. One is flue gas treatment and solid residue treatment and utilization. Now, one more discussion is remain in the chemical transformation, that is another kind of combustion facilities. Now, here the combustion we discussed about in the presence of oxygen. Now, there are few combustion facility which do not require the large amount of air supply, like pyrolysis and gasification process. Although these kind of technologies is not that good for the MSW or mixed MSW, but for separated MSW, especially MSW like the plastic waste, separated plastic waste, separated paper waste, or even agriculture residue, separated agriculture residue also could be possible to utilize into the pyrolysis and gasification process, and we have the large literature available onto that. So, in the next lecture I will just talk about this kind of technology is not that particularly for the MSW, but I will give one lecture onto that pyrolysis and gasification, the advantages, disadvantages of those technologies. Thank you.